My dear all aspirants, response sheets are already provided to you. So, I like to provide the key and solutions of electrical engineering questions, that too for the subjects network theory, electrical power systems, illuminations, batteries. Just you check the key, and if you have any objections, please bring that to our notice. So, let me start here. A set of 3 resistors of 1 ohm each is connected in series with a set of 3 parallel resistors of 1 ohm each. The equivalent conductance of the total set is. First of all, try to understand a question. A set of 3 resistors of 1 ohm each connected in series. So, we have 3 resistors here, resistor 1, resistor 2, resistor 3 here. So, each resistor value is 1 ohm here. They are connected in series, and this whole combination is again connected in series with a set of 3 parallel resistors. So, we have 3 parallel resistors, each resistor value is 1 ohm here, 1 ohm, and this whole combination is connected in series with this combination. Then what about the equivalent conductance? First of all, you find equivalent resistance of this combination. What about the equivalent resistance? Right. So, for this combination here, what about the equivalent resistance? 1 plus 1 plus 1 means here 3 ohms. When resistors are connected in series, the equivalent resistance is directly equal to what here? The sum of the individual resistors. Next, what about the parallel combination here? So, use here R by N here. If N equal resistors are connected in parallel, the equivalent resistance is equal to R by N. R means here the resistance of each resistor divided by number of resistors. So, each resistance value is 1 by number of resistors here 3, 1 by 3. So, this whole combination, for this whole combination resistance is what? 1 by 3 ohms. Then what about R equivalent here? Again these two are in series, means here R equivalent is equal to 3 plus 1 by 3. So, means here 3 3s are 9, 9 plus 1, 10 by 3 ohms. Then what about the conductance? But in this question he didn't ask about the equivalent resistance, but he asked about equivalent conductance. G equivalent equal to 1 by R equivalent means 1 by 10 by 3 means here it is 3 by 10. 3 by 10 value is equal to 0.3 mho. It is not. So, unit for conductance is what? Mho, ohm inverse. So, G equivalent equal to 0.3 mho. It is mentioned in option 1. So, option 1 is the right answer. Right answer. If R1, R2 and R3 are 3 resistances connected in delta, one of the conductance here. So, here let us consider this is a delta network here. The terminals are X, Y and Z. So, let us consider that anyhow here provided what about the resistances of this delta connection R1, R2, R3. Now, this delta connection is connected into star. So, here, so this is connected into star. So, definitely we may get 3 new resistors. So, this is Rx resistor, this is Ry and Rz resistor, Rz. Then what about Rx here? Rx is equal to, this is equal to, Rx is in between R1 and R2. So, R1 into R2 by sum of all these 3 resistors. So, R1 plus R2 plus R3. R1 plus R2 plus R3. Similarly, what about Ry here? Ry is in between R1 and R3. So, Ry is equal to R1 into R3, R1 into R3 divided by sum of the 3 resistors, R1 plus R2 plus R3. Then what is Rz? Rz is in between R2 and R3. That's why Rz is equal to R2 into R3 divided by R2 into R3. Sum of the 3 resistors, R1 plus R2 plus. So, denominator is common in each and every resistor here, R1 plus R2 plus R3. But he mentioned what here? One of the conductance, right? You just find the conductances here. So, if you write the conductances value here clearly, so Gx is equal to 1 by Rs, means reciprocate it here. R1 plus R2 plus R3 by R1 R2. And what about the conductance Gy here? Reverse here, R1 plus R2 plus R3 divided by R1 into R3. Then Gz is equal to, reciprocate here, R1 plus R2 plus R3 divided by R2 into R3. So, one of the conductance is what here? Clear mention R1 plus R2 plus R3 by R1 R2, right? R1 plus R2 plus R3 by R1 R2. So, one of the conductors clearly mentioned in option number 4. So, option 4 is the right answer. The effective capacitance of a parallel plate capacitor which consists of 3 plates is C. Actually, we have 3 plates. So, this is plate number 1, plate number 2, plate number 3. Assume that here the distance between Each pair of the plates is here small d, small d. The area of cross section of each plate is here A, assume. Then the capacitance, between these two plates is here, assume here this is C1, and capacitance between these two plates is C2. Assume that for this whole combination the equivalent capacitance is C dash. But these two here, how many pairs of capacitors are formed here? Two pairs, this one and this one. But they are current in series. Then in series, what about the equivalent capacitance? 1 by C dash equal to 1 by C1 plus 1 by C2. So implies 1 by C dash equal to 1 by C1. Actually for parallel plate capacitor we have the expression here epsilon A by D. For a parallel plate capacitor, the expression for capacitance is epsilon A by D. So what about epsilon A? Epsilon no C. So anyhow here, then 1 by C means here D by epsilon A. So it is what is 1 by C dash equal to 1 by C1 means here 1 by epsilon naught A by D. So it reverse here, D by epsilon naught A plus D by, this is also same here, epsilon naught A. What happened here? So this is 1 by C dash is equal to 2D by epsilon naught A. So finally what happened here? In this case C dash is equal to epsilon naught A by 2D, epsilon naught A by 2D. Later what happened here? Later this distance has been doubled here, distance doubled. Let us consider then equivalent capacitance is C double dash. Then what happened here? 1 by C double dash is equal to then 1 by C1 dash plus 1 by C2 dash. So implies 1 by C double dash is equal to, here C1 dash no, it is double no, means epsilon naught A by 2D, means here 2D by epsilon naught A plus 2D by epsilon naught. There is no change in area of the plates here, just distance is doubled. Then what happened here is equal to, this is 4D by epsilon naught A, then C dash is equal to epsilon naught A by 4D. Previously what we can write here, C double dash is equal to epsilon naught A by 2D by 2, right? This can be written as epsilon naught A by 4D can be written as epsilon naught A by 2D by 2, means epsilon naught A by 2D, already what is epsilon naught A by 2D is C dash. So C dash by 2. What happened here? Capacitance has been halved. So in this question he has mentioned clearly about that the capacitor is having 3 plates. That's why I have done all these things. Without doing all this also we can conclude simply, actually capacitance is given by epsilon naught A by D. When the distance is doubled, automatically what is the mean? Distance is doubled means here the 2 factor is placed in the denominator, automatically what happened here? So we can written as what? Epsilon A by D by 2 means automatically the capacitance is halved. So directly by seeing the expression itself we can tell here. So capacitance is halved. Right. Next question. The field strength H at each end of the long solenoid of length L. So this is a solenoid here. Solenoid means it consists of a long iron piece over which a copper wire is wound on. So provided with a DC supply here. So when the current flows here, so see here, when the current flows through the winding, what happen here? This piece will act as a magnet here, electromagnet. So this is a solenoid. At the center of the solenoid, actually at the center of the solenoid. So if the solenoid is having n number of turns and the current flowing through the solenoid is I and the length of the solenoid is L, means here simply at the center, what about the magnetic flux density means? So it is a mu naught Ni by L, mu naught Ni by L. At center of the solenoid, the magnetic flux density is given by mu naught Ni by L. But at any one of, see, this is one end and this end. At center mu naught Ni by L. Then what about at the edges here? At any one end, this is what B is equal to, if it is at center it is Bi, means it is what, half of this one. The magnetic flux density at center by 2, half of this one. Then what happening? It becomes mu naught Ni by L by 2, means we will get a mu naught Ni by 2L. But we need to find what here? Magnetic field strength H at the end. We need to find here. B is equal to what here? Mu H. From this, what about H? H is equal to B by mu. What is B here? Mu naught at the end. Mu naught Ni by 2L by mu, means here it is mu. So mu naught means gets cancelled here. Ni by 2L. So where it is here? The magnetic field strength at one end of the long solenoid is given by Ni by 2L, clearly given in option 3, clearly given in option 3. So option 3 is the right answer. The assumption of sign convention of while using Kirchhoff voltage law is in a closed circuit. So let me consider a simple closed circuit here. I am going to consider two elements in this closed path here. So this is the voltage source, so whose voltage is Vs, and this is element number 1, this is element number 2. I am providing the polarities like this, plus or minus voltage drop across this element 1 is V1 and voltage drop across this element 2 is what? V2. And if assume that the current flowing in this loop is I. See, if we apply KVL, since we are touching the positive terminal, since the current is touching positive polarity of this terminal 1, so the voltage, its voltage drop is positive plus V1. And here the current is touching is the negative polarity. So that's why we will consider this voltage drop as negative, V1 minus V2, and here minus Vs is equal to 0. Algebraic sum of the voltage drops or potential difference is equal to 0. That is nothing but KVL. But if you see the sign convention, here for element 1, what happened here? Current is for element 1, current is flowing from negative to positive, right? Current 1 is negative to positive. Then we have taken its voltage drop as what? Positive. So V1 is positive then. Then for element 2, the current is, see, for element 2 the current is entering negative and leaving. So current is flowing from positive to negative, positive. For element 2 current is flowing from positive to negative, but we have taken its voltage as what? V2 negative here, negative. Means what here? Voltage drop is positive when the current is in opposite direction. Voltage drop is negative in the same direction of the current. So you just observe the statement here. Voltage drop is positive in the opposite direction of the current. Here positive. Current is flowing from negative to positive, means that it is opposite direction of the current only. When current is flowing from opposite of the, in the opposite of the current, voltage drop is positive. In the same direction of the current, voltage drop is what? Negative. So voltage drop is positive in the opposite direction of the current. Voltage drop is negative in the same direction of the current. So statement B and statement D are wrong. So strictly given here in option 4. So option 4 is the right answer. 1 kilowatt hour of energy is equal to, generally, see, for any form of energy we have the unit, common unit as joule here, whether it is mechanical energy or electrical energy or heat energy, any form of energy, the common unit is joule. But in practice the electrical energy is measured or represented in terms of kilowatt hour. Every month we used to get electricity bill, and the person who takes out the reading of the energy meter, after taking the reading he will convey us that this month you have consumed 100 or 200 units. What about that unit? Unit means that kilowatt hour. 100 units consumed means 100 kilowatt hours are consumed. See, we know pretty well here, the power is always defined as the rate of doing work. So P is equal to W by T. Per power we have the unit here watt. Per work or energy we have the unit joule by second time here. In any format, in any system we have the same single unit for time, that is second. So if you cross multiply, you are going to get here joule is equal to watt second. Okay. Now I would like to convert here 1 kilowatt hour is equal to, so is equal to 1. Kilo means here 1000, kilogram 1000 gram, kiloliter 1000 liter, kilometer 1000 meter. Kilo means 1000, I am writing 1000 as 10 cube into, as it is I am writing watt as it is. Hour means how many seconds are there? 3600 seconds. So here 2 zeros are there, means 100 square, means 100 means 10 square. 10 square into 10 cube, 10 power 5. And what about the numeral remaining here? 36. 36 into 10 power 5. Here watt second. Otherwise 36 into 10 power 5. Watt second means what? Joule. Watt second means clearly joule. So 1 kilowatt hour is equal to 36 into 10 power 5 watt seconds joule. Clearly mentioned 36 into 10 power 5 watt seconds. Option 2 is the right answer. Watt hour efficiency of a cell. See, for a battery, generally the efficiency of a battery can be expressed by two ways. We can express the efficiency of the battery by giving its ampere hour efficiency or by giving its watt hour efficiency. But usually the manufacturers of the batteries use ampere hour efficiency. Why? Because the magnitude of the ampere hour efficiency is usually greater than watt hour efficiency. So in order to attract the consumer, always the manufacturers will print the higher value. So ampere hour efficiency is higher in magnitude. Anyhow, so for batteries, for battery or cell, efficiency is of two types. What are they? Ampere hour efficiency and watt hour efficiency. So ampere hour efficiency means what here? Anyhow, for efficiency means it is output by input, right? Output means that discharging is output and charging is input. So discharge ampere hours by charge ampere hours. So ampere hour efficiency, discharge ampere hours means ID into TD gives us discharge ampere hours by charge ampere hours means IC into TC into 100. Mean discharge current into discharge time gives us discharge ampere hours. Charge current into charge time gives us charge ampere hours into 100. Then what about watt hour efficiency? Watt hour efficiency is equal to here VD means discharge average voltage into discharge ampere hours means ID into TD by here average charging voltage VC into charge ampere hours means IC into TC into 100. So how can we, anyhow, see average discharge voltage into discharge ampere hour by charge voltage, average charge voltage into charge ampere hours. Where it is here clearly mentioned in the option 1 here, ampere hours of discharge means VD into ampere discharge, ampere hours of discharge means here ID into TD into average discharge voltage VD divided by ampere hours of charge means IC into TC into average charge voltage is VC. So this option 1 is the right answer. Option 1 is right answer. Always ampere hour efficiency is greater than watt hour efficiency. The thermal efficiency of a 1000 watt 220 volt electric heater is 84%. How long will it take 3 liters of water to heat from 20 degrees centigrade to 100 degrees centigrade, assuming mechanical equivalent of heat is 4.2 joule per calorie. So we have an electrical heater which is rated for 1000 watts and 220 volts. Its thermal efficiency. So thermal efficiency is given here. So output power divided by input power. So into 100, which is equal to what here? Which is equal. Then percentage theta is equal to what here? Output power by input power. So it is already given how much here? 84% means here it is 0.84. Then what about the output power here? Output power is equal to, if you cross multiply, 0.84 into input power. But input power is clearly mentioned 1000 watts. So 0.84 into 1000. How much it is? If you multiply 0.84 with 1000, you are going to get what? 840 watts. 840 watts. Okay. Then here how much amount of heat energy is required to raise the water temperature from 20 degrees centigrade to 100 degrees centigrade, right? See, in order to raise the temperature of the water from 20 degrees centigrade to 100 degrees centigrade, so we need to supply some amount of heat energy, right? So amount of heat energy, so heat energy required to raise water temperature from 20 degrees centigrade to 100 degrees centigrade is, I am going to use here Q is equal to M into S into delta T. M is mass of the water and S is specific heat of the water. So M is mass of the water. It is what here 3 liters given, but nothing but 3 liters approximately equal to 3 kilograms. Specific heat of the water is what here 4200. You please remember here 4200 here 4200 joules per kilogram Kelvin. Here this is what specific heat of the water. Specific heat of the water. Temperature difference delta T is equal to what here 100. Final temperature 100 degrees centigrade. Initial temperature minus 20 degrees centigrade. So how much here? It is 80 degrees centigrade. Just substitute the values here. So Q is equal to M means what here? Mass 3 kilograms into S. S means here 4200 into 80, right? 80. So here you are going to get in terms of joules only, in terms of joule. But we know pretty well here. What about here? power is equal to energy by time. From this, energy is equal to power into time. From this, what is about time here? Time is equal to energy by power here. So what about the heat energy required? Is nothing but work is nothing but heat energy, Q by P here. So you have both values here. Q is number 3 into 4200 into 80. 3 into 4200 into 80 divided by, what about the output power? P means the output power is 840 watts. 840 watts. So simplify here, 0, 0 cancel. 4 2 ja 8, 4 2 ja 8, 4 1 ja 4 here. So 21 1 ja, and here what happened? 21 2s 200. So 2 into 3 6, 6 into 2 into 3 6, 6 into 1200 seconds. But we need to consider about in terms of minutes. Options are given in terms of minutes right here. So 1200 divided by 60 minutes. How much here? It's equal to 0, 0 cancel, 6 1 ja, 6 20 ja. So 20 minutes. Clearly we got here 20 minutes. So it takes 20 minutes time for raising the water temperature from 20 degrees centigrade to 100 degrees centigrade. So option 1 is the right answer. Which of the following is not a property of magnetite? Generally, magnetite is a ore of iron here. So generally, iron can be extracted from magnetites. So one more ore is hematite. So what about the chemical formula for magnetite? Means here Fe3O4. Anyhow, if you observe the properties of the magnetite, just go through the options here, but we need to pick it out. What is not a property of magnetite? So actually, the property of its magnetic property is similar to iron. Of course, here since magnetite is a ore of iron, the magnetic property of magnetite is similar to iron. This is right statement only. It has very high resistivity. Yes, magnetite is not a good conductor here, so its resistivity is usually high only, right? And it has a lower initial permeability compared to nickel. Nickel iron alloy is a good magnetic material. Nickel iron alloy has a higher permeability. When you compare the permeabilities of magnetite as well as nickel iron alloy, the permeability of magnetite is generally lower. Is this also correct here? And it is not a semiconductor. Anyhow, of course here, see here, generally hematite, if you see the properties of hematite, actually this semiconductor, this statement is not all related to magnetite. Magnetite is neither perfect conductor nor perfect insulator. Somehow it is an intermediate conductor, nothing but semiconductor only. So that's why it is not a semiconductor. So this statement is not a property of magnetite, So option 4 is the right answer.
Right. So we'll go for the next question. So next question చూడండి ఏం అడిగాడు? Identify the wrong statement with respect to Megger. సో మెగ్గర్కి సంబంధించి రాంగ్ స్టేట్మెంట్ ఏంది అని అడిగాడు. అసలు ఫస్ట్ మెగ్గర్ ఏం కనుక్కుండిద్ది సార్? ఫస్ట్ మనకి తెలుసుకోవాల్సిన విషయం ఏంటిది అంటే హై రెసిస్టెన్స్ని కనుక్కుంటుంది. హై రెసిస్టెన్స్. సో హై రెసిస్టెన్స్ని కనుక్కునేది ఏంటిది అంటే మెగ్గర్లో మనం నల్ డిఫ్లెక్షన్ వాడతాం. ఎందుకు? మనం డీసీ బ్రిడ్జెస్లో అన్నిటిలో వాడేది ఇదే. ఓకేనా? రైట్. సో మెగ్గర్లో మనం ఇంకా ఏం చెప్పొచ్చు సార్ అంటే మెగ్గర్ యొక్క మ్యాక్సిమం స్పీడ్ ఎంత అంటే 160 RPM. సో ఎప్పుడైతే మనకి మెగ్గర్ యొక్క మ్యాక్సిమం స్పీడ్ ఎంత అంటే 160 RPM. దీంతో పాటు మెగ్గర్ని నువ్వు ఎలా చెప్పొచ్చు అంటే సిరీస్ టైప్ ఓమ్ మీటర్ ప్లస్ డిసి జనరేటర్, ఈ రెండు కలిపితే మనకు వచ్చేదే మెగ్గర్. ఈ 3 పాయింట్లు మనకు గుర్తున్నాయి అంటే ఆటోమేటిక్గా మనకి ఇక్కడ ఇచ్చిన క్వశ్చన్కి ఆన్సర్ వచ్చేస్తుంది. ఇంకా ఏం చెప్పొచ్చు మెగ్గర్ నుంచి చూడండి. ద రీడింగ్స్ ఆఫ్ ది మెగ్గర్ ఆర్ డిపెండెంట్ ఆన్ ది స్పీడ్ ఆఫ్ ది సెల్ఫ్ కంటైన్డ్ జనరేటర్. సో డీసీ జనరేటర్ ఉంది కాబట్టి ఆప్షన్ 1 అనేది మనకి కరెక్ట్ ఆన్సర్. డిఫ్లెక్టింగ్ ఆఫ్ మూవింగ్ సిస్టమ్ డిపెండ్స్ ఆన్ ది రేషియో ఆఫ్ కరెంట్స్ ఆఫ్ ది కాయిల్. నో, కాదు. నెక్స్ట్, డిఫ్లెక్టింగ్ ఆఫ్ ది మూవింగ్ సిస్టమ్ ఈజ్ ఇండిపెండెంట్ ఆఫ్ అప్లైడ్ వోల్టేజ్. కాదు. మూవింగ్ సిస్టమ్ కన్సిస్ట్ ఆఫ్ 2 కాయిల్స్ విచ్ ఆర్ 90 degrees అపార్ట్. ఇది కూడా కరెక్టే. ఇవన్నీ కరెక్ట్లే, కానీ ఇది ఒక్కటి మాత్రం మనకి తప్పు. రాంగ్ స్టేట్మెంట్ అని అడిగాడు. మనకి డీసీ జనరేటర్ ఉంది కదా అని దాని మీద డిపెండ్ అవుతుంది అంటే రాంగ్, డిపెండ్ అవ్వదు. అందుకని ఇది రాంగ్ స్టేట్మెంట్. ఓకేనా?